Hey everyone! Today we're going to start Chapter 3, and Chapter 3 is all about scientific measurement. So, unfortunately, this is your math chapter, which is going to cover things like scientific notation, significant digits, temperature conversions, density, and even when we get to conversion factors. So, I split this section into a lot of different parts. So we're going to cover 3.1, but not all of it. We're only going to cover part of it. So let's get started. This section starts out with a question saying, how do you measure a photo finish? If you are in track, if you run the 100-meter race or 200-meter race, they run pretty fast, and sometimes people come in around the same time. So sprint times are often measured to the nearest hundredths of a second. In case you don't know what hundredths of a second is, this place value is the tenths. This one is the hundredths. So it's measured out 2 decimal places. And chemistry also requires making accurate and usually very small measurements as well. So let's talk about a measurement first, since this section is called using and expressing measurements. Well, a measurement is a quantity that has both a number and a unit. So for example, your height, 66 would be the number, and inches would be the unit. Your age, 15 would be the number, years would be the unit. Even body temperature, so 37 would be the number, and degrees Celsius would be the unit. All measurements need a unit, because if I just say I'll be there in 5, does that mean 5 seconds because I'm almost in the driveway? 5 minutes because I'm just leaving home? Or 5 hours because I just left another state? So you need to know that unit. So we're going to head into our first section that we're going to learn about. It's called scientific notation. And we have to learn this because in chemistry, we're going to work with very, very large numbers and very, very small numbers. So a single gram of hydrogen contains this many hydrogen atoms. And I'm going to tell you right now, that's a lot of zeros. You do not want to write this number every single time that you want to write down how many hydrogen atoms there are. So we can take this very, very, very large number and work with it easier by putting it into scientific notation. So you can work more easily with very large numbers or very, very small numbers by putting them in scientific notation. So what exactly is scientific notation? I've been saying this word, but for many of you, you might be like, what? So scientific notation is a given number, and it's written as the product of 2 numbers, a coefficient and 10 raised to a power. So for example, that very, very, very big number that we had, if I were to write in scientific notation, it would be 1.6 times 10 to the 23rd. So let's break down that definition in terms of what scientific notation looks like. The coefficient is that number in front of the multiplication sign. So again, that 6.02 is the coefficient. Now this says the product, so that's why I have a multiplication here. So product. And then it says and 10 raised to a power. So this is your power. That power is often called an exponent. So how do you write numbers in scientific notation? You saw what it looks like, but we have to be able to write them. Well, in scientific notation, the coefficient, remember, that's the number out front, is always a number that is greater than or equal to 1 and less than 10. And your exponent is an integer. So if you're not sure what an integer is, it's usually a whole number. So it can be 1, 2, 3, 4, it can be 24, as long as it's a whole number and it doesn't have any decimals. So a positive exponent tells me how many times my coefficient, or again that number out front, was multiplied by 10. A negative exponent tells me how much that number out front or that coefficient was divided by 10. So when writing numbers in numbers greater than 10 in scientific notation, usually our exponent is positive, and it equals the number of places that we originally had to move. So let's look at a few examples here. We are given 6,300,000. Usually, if you do not see a decimal in the number, it's located at the end. So here you can see the decimal at the end. We want this number to be between 1 and 10. So right now, that number is not between 1 and 10. So I have to move my decimal over. So 1, 2, 3, 4, 5, 6. I have to move my decimal here because if I leave it here, I have 63, and that number is not between 1 and 10. If I move my decimal here, I have 6.3, and 6 is between 1 and 10. So that's how I got the 6.3. Then you have to write times 10. And the way they got this 6 right here is because I moved 1, 2, 3, 4, 5, 6 spots. Last thing to check is that this is a positive 6 because this number was greater than 10. Another example right here is 94,700. So your decimal is at the end of the number in this number. I have to get a number between 1 and 10, so I have to move it 1, 2. If I only move it here, my number is 947. So I have to keep going. If I move it here, my number is only 94. So I have to move it one more time, and that gets me 9.47. That number is less than 10 and is greater than 1, so it is good. So then I put times 10. So they got this 4 again by moving it 1, 2, 3, 4 spots. And it is a positive number because this number right here is greater than 10. Now numbers less than 1 are going to have a negative exponent when you write the little exponent up here. And the value of the exponent is equal to the number of places, again, that decimal has moved right. So the reason I have to move my decimal is because right now my number is not between 1 and 10. So I actually have to move it back behind the 8. So that 8 is, yes, a number between 1 and 10. Now I had to move it 1, 2, 3, 4, 5, 6 times. Since I had to move it 6 times, that's why this number right here is 6. Now the reason this is a negative is 1, because I moved it right, but also because this number is less than 1. So it's a very tiny number, so it gets a negative exponent. Same thing over here. I have to move it 1, 2. So 1, 2, 3. So I had to move it 3 times. So right here, if I moved it 3 times, my number is 7. That is between 1 and 10, 7.36. And the reason I got a 3 here is because I moved it 1, 2, 3 times. And it's a negative because this number is less than 1. So let's try to work out some examples. So I want you to pause this video and try to work some of these out yourselves, and then check and see if you got them right. Okay, so let's kind of walk through some of these. So right here we have 14,568. If you do not see a decimal in a number, it's always going to be at the end. So right now is the decimal at the end. You want this number to be between 1 and 10, so you have to move it 1, 2, 3, 4 to the left. So I get 1, and my new decimal is right there. So I got to put my new decimal there. Then I have 4, 5, 6, 8 times 10. And then again, my number up here is based on how many times I moved, and I moved 4 times. Now I have to determine if that's going to be positive or negative. And since this number is bigger than 10, this is positive. On example number 2, my decimal is at the end because I don't see a decimal in this number, and I have to move over 1, 2, 3, 4, 5. So if my decimal is now there, I have to put my decimal after the 1 because that's where I moved it. and I get 1.27 times 10. And again, I count how many times I moved it, and I moved it 5 times. And you notice that's going to be positive because this number is bigger than 10. Next, we have example number 3. So 1, 2, 3. And my new number is 7. Make sure you put your decimal. 8, 9 times 10 to the third. Now you just can't leave your answer like this because it will be wrong. Since this number is less than 1 and I move to the right, it should be a negative 3 here. So that's a negative 3. Now how did I know to move it to the right? Well, because if I moved it to the left, my number would never be between 1 and 10. So you have to move to the right. So over here, 1, 2, 3, 4, 5, 6. So 4.7 times 10 to the negative 6, since this number is less than 1. Now right here, my decimal is located right here, and we've never had a decimal located within the number. The same thing works. Right now, my number is 203. If I move it over, it's 20, so it's not quite between 1 and 10, so I have to move it over one more time. So when I move it over one more time, it becomes 2.034 times 10 to the, and I moved it twice. And this one, 1, 2, 3, 4, 7.80971 times 10 to the fourth. And both these are positive because those numbers are greater than 1. So if you had any trouble with those, make sure that you ask questions. I can do more examples with you. And hopefully you did pretty well on those, and you can check your answers. So when we go on to multiplication and division, to multiply numbers written in scientific notation, you multiply the coefficients. Remember, the coefficients are the numbers out front or before the multiplication sign. And then you add the exponents. So remember, exponents are these little guys right here. So if I wanted to take 3 times 10 to the fourth and multiply it by 2 times 10 to the second, the numbers out front are 3 and 2. So you multiply those to get 3 times 2 to get 6. Then again, your exponents, 4 and 2, you want to add those. So 4 plus 2 gives me 6. So your number you would get is 6 times 10 to the sixth. Here's another example. 2.1 times 10 to the third times 4.0 times 10 to the negative seventh. Again, you multiply the numbers out front, 2.1 and 4, and you get about 8.4. And then these exponents, you have to add them. So 3 plus a negative 7. So 3 plus negative 7 gives you a negative 4. Division is going to be the opposite. Instead of multiplying the coefficients, you're going to divide the coefficients. And the exponents, instead of adding them, you are going to subtract them. So here, divide the numbers out front. So 3 divided by 6 gets me 0.5. And then you would subtract the exponents. 5 minus 2 gets me 3. Now right here, you may see a number. I always ask the class, is this improper scientific notation? If you said no, you are correct. The reason this is not improper scientific notation is because this number right here is not between 1 and 10. So in order to get the number between 1 and 10, I move the decimal to the right to get 5. And since I moved the decimal to the right, I actually had to subtract 1 because this number is less than 1. So it would be same as 3 minus 1 gets me 2. So 5.0 times 10 to the second is correct. Okay. Addition and subtraction are a little bit different. I don't make you guys add and subtract numbers in scientific notation for homework because most things that you see in science are going to be adding or multiplying or dividing. So I just tell you how to add. So if you want to add or subtract in scientific notation and you're not using a calculator, all you have to do is make sure that your exponents are the same. So in other words, when you make your exponents the same, the decimal points add up. So here's an example that your book does. Again, you will not see this on your homework, but I do like to touch on it in case you ever do see it. So if I take 5.4 times 10 to the third and 8.0 times 10 to the second, and I want to add those, you're going to notice the exponents are different. So I have a 3 and a 2. In order to add those, the exponents have to be the same. So I can make them both 3s or make them both 2s. This example makes both of them 3. So in order to make this exponent 3, I have to move my decimal to the left. And so when I move my decimal to the left, it becomes 0.8 times 10 to the third. And then what we do is we can add. So for example, we add these numbers out front. 5.4 plus 0.8 gets me 6.2, and of course the exponent's going to be the same. Okay. So we're going to solve each of these problems and express the number in scientific notation. So what I want you to do is pause this video and then see if you can solve these, and then we will go over them as a class. So you guys solve those. Okay. So first thing you should ask yourself is, what order of operation am I doing between these exponents? And you can see right here that we are multiplying. So whenever you multiply, you need to multiply the numbers out front. So if you go on there and you put 8 times 7 into your calculator, if you don't know it, you get 56. And then you say times 10 to the, and then what you need to do is add your exponents. So you would put in here -2. So make sure you know how to put a negative sign into your calculator. -2 plus -5. So make sure again you know how to put your negative signs in. Should get you -7. So 56 times 10 to the -7. Then you have to ask yourself, is this in proper scientific notation? And if you said no, your answer is correct. And it's because your decimal is right here. This number is not between 1 and 10. So in order to get a number between 1 and 10, I have to move my decimal to the left, which gets me 5.6 times 10. Since I moved my decimal to the left, this of course is going to change my exponent. I'm going to have to add 1 since this number is bigger than 1, or bigger than 10 as well. So -7 plus 1 gets me -6. Over here, I'm not going to have you do the addition one because you guys will not be doing it on your homework. So you guys are good there. So again, here is how they work through it. To multiply numbers in scientific notation, multiply the coefficients and add the exponents. Again, if you're going to add, the exponents must match. So here they multiplied the numbers in front like we just did and got 56. And then they added the exponents to get -7. 56 is not in proper scientific notation, so they moved the decimal to the left, which added 1. So -7 plus 1, that's how they got that -6. If you actually wanted to know how they added it, again, which I told you did not have to do, what they did is they got both of those exponents into -2. The way they got 5 times 10 to the third into -2 is by moving the decimal 1 to the left. And when they did that, since they moved to the left, it added 1. So -3 plus 1 gave you -2. Then to add, you add the numbers out front, and then you keep the same exponent. So here it says the mass of one molecule of water written in scientific notation is 2.99 times 10 to the -23rd grams. And it wants to know standard notation. So standard notation is decimal form. We have not learned this, so I'm going to teach you coming up. In order to do decimal form, you undo what you did to get it into scientific notation. So here you have 2.99 times 10 to the negative 23rd. If you have a negative number, you want to move to the left. What I always tell my kids is that since you have a negative number, you want to make this number smaller. So what I would do is I would find my decimal and move it to the left 23 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. And then my new decimal goes out here. And you know what I do with all of these little spots that I moved it? You would have to fill it in with decimals. So zeros. So you would keep filling this in with zeros until you get to the end. So the mass of one molecule of water in standard notation is a bunch of zeros. So let's actually try writing these in standard notation so I can teach you. So these are some examples that we're going to walk through to help teach you how to take things out of scientific notation. So right here, I have my coefficient and I have my exponent. So when you have something in scientific notation, you want to take it to standard. That means you want to move this decimal however many times your exponent tells you to. So here, this is telling me I need to move my decimal 5 times. Common question I'm going to get is, which direction do I move it? Well, you're going to move the direction based on if this is a positive or a negative. So positive exponent, you're going to move right. If you have a negative exponent, you're going to move left. So you don't have that in your guided notes, so I want you to add that. So for example here, I have 1.02 and I have a 5. So if it's positive, it move right 5 times. So I put where my little decimal's at. I move it 1, 2, 3, 4, 5. And that's where my new decimal is going to go. So what you would do with these empty spaces is fill them in with zeros. So this number now becomes 102,000 with my new decimal at the end. Now what if the opposite is true? What if you have a negative exponent? Here I said move left. So if you have 0.45 and you have a negative 2, that's negative tells me I'm going to move left 2 times. So I'd find my decimal and go 1, 2. So here you fill these in with zeros. So my new number becomes 0.0045. So I want you to try these bottom two by yourself and see what you get. So I want you to pause the video and try them yourselves. Okay, so right now we're going to walk through it. Here I have 6.3. This positive exponent tells me that I'm going to move right, and I'm going to move right 3 times. 1, 2, 3. Again, you fill in these spaces with zeros. So my new number becomes 63,000 or 6,300. Right here, I have 10.06 times 10 to the negative 5. So that negative tells me to move left 5 times. So I have to find my decimal. Move over 1, 2, 3, 4, 5. So I get a 0, 0, 0. So my new number becomes 0.001006. So that is the end of my lesson with doing scientific notation. If you have any questions, you have to make sure you ask me. Math is sometimes a little bit difficult, so if you struggle, I am here to help because I don't want you to fall behind. Okay, have a good day.